Miljoy Cisosa again for Cisco networking subject. I'm here to discuss about the OSI, IP, decapsulation, encapsulations, and anything that is about networking. So if you're interested in this video, please keep on watching. Thank you. In brief introduction, the TCP and IP model. The TCP and IP model was developed prior to the OSI model. Then the TCP IP model is not exactly similar to the OSI model. The TCP IP model consists of 5 layers: the application layer, transport layer, network layer, data link layer, and physical layer. The first 4 layers provide physical standards, network interface, internetworking, and transfer function that corresponds to the first 4 layers of the OSI model, and these 4 layers are presented in TCP IP model by a single layer called the application layer. So the TCP IP is hierarchically protocol made up of interactive modules, and each of them provides specific functionality. Hierarchical means that each upper layer and protocol supported by 2 or more layer level protocols. So then let's proceed to the discussing about those layers. The network access layer. A network layer is lowest layer of the TCP IP model. A network layer is the combination of physical layer and data link layer defined on the OSI reference model, and it defines how the data should be sent physically through the network. This layer is mainly responsible for transmissions of the data between 2 devices on the same network. The functions carried out by this layer are encapsulations, the IP datagram into frames by network, and mapping of IP addresses into physical addresses. The protocol used by this layer are Ethernet, token ring, FDDI, and X.25 frame relay. Then let's proceed to the internet layer. An internet layer is second layer to the TCP IP model. An internet layer is also known as the network layer. The main responsibility of the internet layer is to send the packets from any network. They arrive at the destinations respective to the route they take. IP protocol is used in this layer, and it is the most significant part of the entire TCP IP set. Let's proceed to the IP addressing. IP addressing is this protocols implements logical host addresses known as IP addresses. The IP addresses are used by the internet and higher layers to identify the device and provide internet work routing. Host-to-host communications, it determines the path through which the data is be transmitted. Then data encapsulation and formatting. An IP protocol accepts the data from the transport layer protocol. An IP protocol ensures that the data is sent and received securely. It encapsulates the data into message known as IP datagram. Fragmentation and resemble, the limit imposed on the size of the IP datagram by data link layers protocol is known as the maximum transmission unit or MTU. The size of IP datagram is greater than the MTU unit, then the IP protocol splits the datagram into smaller units so they can travel over the network. Then fragmentation can be done by the sender or intermediate router. At the receiver side, all the fragments are reassembled for form a regional messages. It was break it into tiny pieces, then reassemble it again if it reached their destinations. Then let's proceed to routing. When IP datagram is sent over the same local network such as LAN, MAN, WAN, it is known as directly delivery. When source and destination are on the distance network, then the IP datagram is sent indirectly. This can be accomplished by routing an IP datagram through various devices such as routers. Let's proceed to the Next topic is the ARP protocol. The ARP protocol stands for Address Resolution Protocol. ARP is network layer protocol which is used to find physical address from the IP address. The two terms mainly associated by the ARP protocols are the ARP request and ARP reply. In ARP request, when a sender wants to know the physical address of the device, it broadcasts the ARP request to the network. While the ARP reply, every device attached to the network will accept ARP request and process the request, but only recipient recognize the IP address and sends back its physical address in the form of ARP reply. The recipient adds the physical address both to its cache memory and to the datagram header. So that's all for the ARP protocol. Let's proceed to sa ICMP protocol. Stands for Internet Control Message Protocol. It is mechanism used by the host or routers to send notifications regarding datagram back to the sender. A datagram travels router to router until it reaches its destination. If a router is unable to route data because of some unusual conditions, such as disabled links, device on a fire, or network congestion, ICMP protocol is used to inform the sender that the datagram is undelivered. In this protocol, two terms are used, the ICMP test and ICMP reply. The ICMP test is used to test whether the destination is reachable or not, while this ICMP reply is used to check whether the destination device is responding or not. The core responsibility of the ICMP protocol is to report the problems, not correct them. The responsibility of the correction lies with the sender. ICMP can send the message only to the source but not to the intermediate routers because the IP datagram carries the addresses of the source and destination but the router that is passed to. So let's proceed to the transport layer. The transport layer is responsible to the reliability, flow control, corrections, data which is being sent over the network. The two protocols used to the transport layers are User Datagram Protocols and Transmission Control Protocol. User Datagram Protocol or UDP, it provides connectionless servers and end-to-end delivery of transmission. It is an unreliable protocol as it discovers the errors but not specify the error. User Datagram Protocols discovers the error in the ICMP protocol, reports the error, and sender and the user has been damaged. The UDP consists of source port addresses, destination port addresses, total length checksum. In checksum, 6-digit field used in error detection. So, let's proceed to the application layer. An application layer is the topmost layer in the TCP/IP model. It is responsible for handling high-level protocols issue representations. There is ambiguity occurs in the application layer. Every application cannot be placed inside the application layer except those who interact with the communication system. For example, text editor cannot consider the application layer, while web browser using HTTP protocol can interact with network, where HTTP protocol is an application layer protocol. HTTP means Hypertext Transport Protocol. This protocol allows us to access data over the World Wide Web. It transfers the data from form, plain text, audio, video. It is known Hypertext Transport Protocol. It has efficient to use hypertext environment where there are rapid jumps from one document to another. So, SNP stands for Simple Network Management Protocol. It is framework used for managing device on the internet by using the TCP/IP protocols. DNS stands for Domain Name System. An IP address is used to identify to connections. So that's all for the video, for the topic about computer networking. I hope you understand more about networking. So Thank you.